Okay guys, yesterday we took some notes on mechanical advantage and what that is. So today you're going to be doing a simple lab that's going to help you see what the mechanical advantage is of some simple hand tools that we commonly use, like scissors in this case. So of course these papers will be tacked up on the pegboard, and next to them I have a example. I don't know how well this will show up on the screen here, but there is an example of a previous year's assignment. So let's take a look at what you're going to be doing. I've already traced the outline of my tongs. These are going to be a common tool at every table. Some of the others are going to be different. So I've traced the outline, as you can see on my tongs. I've already traced those. So I'm going to move that out of the way. That'll be your first step. And then you can see that I drew two lines on the widest part of both the handle over here and on the tong part, which is over here. So you now have your distance of resistance on the left and the distance of effort, that's what your hands are doing, on the right. So what you're going to do is trace a line, or make a line using the rulers, and you're going to figure that distance out in millimeters. Now remember, the numbers on the ruler are centimeters, and remember that there are 10 millimeters in 1 centimeter. So in this case, I'm not going to calculate it for you because I want everybody to do this one, but you can figure out that if you have 10 centimeters, that's going to be 100 millimeters. So again, we're doing this in millimeters just for simplicity's sake. So make sure that you're recording that information in that manner. Once you have that, you can set up the equation at the bottom of your paper or side, however it works best for you. IMA, ideal mechanical advantage, equals the distance of effort divided by the distance of resistance. And you are, once you put your numbers in here of the opening here and the opening here, then you're going to calculate that, and you're either going to see a gain in force or a gain in distance, or it's possible that you may not see a gain in force or distance if it's exactly 1. In that case, you're just seeing a change in direction. So that is a possibility too. I did not write that down here. So there's going to be one of 3 different types of ideal mechanical advantage. You're going to do that for each, or for 3 hand tools. All right. And then after you do your calculations, you're going to need to write what the advantage is. Is it a gain in force? Is it a gain in distance? Or is it simply a change in direction, no gain? And that will be that. Once you're done with that, please make sure you can conserve paper if you'd like, using the front and back. If it's too hard, some of the tools are pretty big, so you won't be able to do more than 1. Some of them you can do 2 on 1 page. It's up to you if you want to do it that way. Make sure that your name is on there. Make sure that your equations are clearly labeled for which tool they go with. Staple your papers together and put them in your class's in bin. Once you're done with that, the next assignment is to work on some IMA practice problems, like you worked on the work practice problems the other day. So I'll distribute those as you're finished with the lab. Go to it.